Hello. Ah, i-discuss ko ngayon yung about sa measurements and kung paano ito nagagamit ng mga chemist sa pag-calculate. Hindi lang ng chemist kundi ng lahat ng mga scientist sa pagka-calculate. So, the measurement ay ginagamit natin sa pag-calculate para makuha natin ang mga certain quantities na gusto nating makuha. So, meron tayong iba't ibang instrument na ginagamit sa pag-measure ng mga substance. So, katulad ng meron tayong meter stick para ma-measure natin, for example, ang length or scale. So, meron tayong burette, pipette, graduated cylinder, and volumetric flask para ma-measure ang volume, specifically sa volume ng liquid. Ito yung isang picture ng burette, pipette, graduated cylinder, and volumetric flask. Yon. So, itong mga instrument na ito ay nagpo-provide ng measurement ng macroscopic property. Ano nga bang macroscopic property? Ito yung mga property na nadidetermine natin directly. Meron naman tayong tinatawag na microscopic property. So, ano yun na microscopic? So, ano yun? Atomic or molecular scale. Nasa atomic or molecular scale siya. So, it can be determined through an indirect method. So, i-discuss natin yun sa mga susunod na mga videos. So, a measured quantity ay usually nakasulat ng merong unit. Merong unit of measurement. So, for example, kung halimbawa, magta-travel ka from Manila to Quezon City, Manila City to Quezon City. So, may distansya yon. And you will express the distance with a unit, such as kilometers or miles. Hindi ka pwedeng magsabi na ang distansya from Manila to Quezon is only 5,000. 5,000. 5,000 what? 5,000? It should be 5,000 kilometers or miles. There must be a unit. So we must specify that the distance is 5,000 kilometers, for example. So parehas din sa chemistry. Kailangan nating i-state kung ano yung unit of measurement niya correctly. So ang susunod na i-discuss ko dito ngayon ay yung tinatawag nating SI unit. Kasi ito yung usual na ginagamit natin sa pag-express ng mga unit of measurement. So for many years, scientists recorded measurements in metric units, so which are related decimally. So mas madali ito kumpara sa English or customary unit kasi ito, kumbaga, ay ang ano niya, factor niya is by power of 10. So in 1960, however, the General Conference of Weights and Measures, which is the international authority of units, nagpropose sila ng isang revised metric system na kung tawagin ay International System of Units. So ang abbreviation nito ay SI, coming from the French. It is actually French. System International de Units. So I will show you a table of the 7 SI base units. So this is the SI or the base units. So kumbaga, itong mga units na to ay hindi derived from other unit. So ito na kumbaga yung kung sa mga numbers, ito na yung prime number ba? Yeah. Ito yung prime number, hindi siya composite. Okay. So kumbaga siya na yung pinaka-base. So yung meron tayong length, which is a base quantity, tapos ang unit na ginamit ng SI is meter. Then ang symbol niya is the lowercase m. We have the mass, and the name of the unit is kilogram. Then ang symbol niya is lowercase kg. And we have for time, the name of unit is second, and the symbol is lowercase s. We have electrical current. The name of the unit is ampere, and the symbol is uppercase A. We have temperature. The name of the unit is Kelvin, and the symbol is uppercase K. The amount of substance. The name of the unit is mole, and the symbol is MOL, lowercase. Then we have the luminous intensity. Ang name of unit niya is candela, and the symbol is CD. So, siguro dito sa chemistry, ang magagamit natin usually dito ay mass, length, sa kinetics, kailangan din natin ng time, temperature, and of course, the amount of substance. So, yun. Siguro sa electrochem, meron din current. But this luminous intensity, pang physics ito, na ano, I don't know. But perhaps sa mga susunod na video natin, hindi natin siya magagamit, itong candela. So, okay. All other units of measurement, sabi ko nga, ay pwedeng ma-derive from that base model. Base units. So, for example, sa metric unit, like metric units, SI units of measurement can be modified in decimal fashion. So, ano nga bang, halimbawa, meron tayong mga mini-measure na sobrang lalaking mga for example, sobrang bibigat. We are measuring the mass ng sobrang bibigat na mga matter. Hindi tayo gagamit ng kilogram lang, kundi gagamit tayo ng certain prefix na mas appropriate sa bigat nung natin mini-measure. Ito, ipapakita ko yung table 1.3. This is the prefixes na ginagamit para sa mga SI unit. We have the tera, which means 10 to the 12 power. So 1 terameter, for example, 1 terameter, meron tayong capital T at meron tayong small letter m, which denotes the meter, is equal to 1 times 10 exponent 12 meter. And then we have giga for 10 raised to 9. We have mega 10 raised to 6, kilo 10 raised to 3. So, ito yung usual na ginagamit natin sa pag-measure ng halimbawa bigas, ng mga commodities, that is kilogram, 'di ba? Kung nasa mass tayo. Kung sa distance naman tayo, kilometer, that is 1,000. That means 1,000. Pero kung siguro medyo mas mabibigat na, megagram na ang gagamitin natin. So the base unit is gram, then we will add the prefix with megagram. Kung sobrang liliit naman, we will now go to sa dimension ng mga particles na sobrang liliit. Nanotechnology. So ito, nano, which means 10 raised to negative 9. It means it means a billionth of a meter. So you will divide the meter stick, for example, because that is 1 meter, you will divide it by 1 billion. Then the length of one of those parts is a nanometer. Okay. Measurements that we will utilize frequently in our study of chemistry include time, mass, volume, density, and temperature. So, nasabi ko na yun kanina. So, mapunta tayo sa mass and weight. Yung term na mass and weight, sometimes napagpapalit natin. Although, strictly speaking, they are different quantities. Ang mass, it is a measure of the amount of matter in an object. So, kung tutusin, it is something that is constant. Like for example, ang 1 kilong bigas ay 1 kilong bigas yan. Yan ang mass niya. Isang kilong cotton, isang kilong cotton siya. Regardless kung saan man siya. Kung regardless man kung anong location niya or nasaang parte siya ng mundo. Okay? Yung weight, technically speaking, it is the force that gravity exerts on an object. So, for example, an apple that falls from a tree is pulled downward by Earth's gravity. So, the mass of the apple is constant. Constant yun. Sabi ko kanina, constant ang mass. Pero, yung weight niya ay nagbabago. Depende sa location. Depende kung nasaan siya nakalocate. So, for example, kung yung apple mo ay nasa moon, which has a gravitational force, 1/6 of that of the Earth's gravitational force, then yung weight ng apple doon, although the same ang mass niya, ay magkakaroon ng 1/6 of its weight niya dito sa Earth. So, yun. The moon's smaller gravity enabled yung mga astronaut natin na makapag-jump freely sa surface nito kasi nga ang gravity doon ay weaker, kumbaga hindi strong ang force ng gravity doon kumpara dito sa Earth. Okay? So, we are interested primarily sa mass, which can be determined readily by a balance. So, the process of measuring mass is called weighing. Kaya medyo nagkakaroon tayo ng kalituan kasi yung tawag dun sa sa pagkuha ng mass ay weighing. But we are actually getting the mass and not the weight of that particular object na tinitimbang natin. Yung SI unit para sa mass ay kilogram, kg. So unlike sa unit ng length and time, which are based on natural processes that can be repeated by scientists anywhere, yung kilogram is defined in terms of a particular object. Sa chemistry, yung smaller gram, yung mas maliit sa kilogram of course, which is 1,000 of kilogram, yun ang mas usual na ginagamit natin. Okay. Punta naman tayo sa volume. Ang volume, ang SI unit naman natin ng volume ay meter. And it is an SI derived unit. Dinerive siya sa length. Length cube. So, length times length times length. So, ang SI unit niya is cubic meter. So, generally, however, tayong mga scientists work with a much smaller volume. Sa mga mas maliliit tayong volume, minsan nagfo-focus. For example, gumagamit tayo ng cubic centimeter, which is cm raised to 3 or cubic decimeter. So, ito yun. Okay. Ang isang cubic meter, 'di ba, ang isang centimeter ay 1 times 10 to the -2 meter. So para makuha natin yung equivalence niya into cubic meter, kailangan natin i-cube to. So pag kinube natin siya, kinuha natin yung cube nito na nakaparenthesis, magiging siyang 1 times 10 exponent -6 cubic meter. That is the equivalent of 1 cubic meter. 1 times 10 exponent -6 cubic meter. 1 cubic decimeter is equal to, di ba ang 1 decimeter is 1 times 10 exponent -1 meter. I-cube natin to, which is equal to 1 times 10 exponent -3 cubic meter. So 1 cubic decimeter is equal to 1 cubic meter. So Another common unit of volume is liter. So, may liter pa. So, ang liter is a volume occupied by 1 cubic decimeter. Ang equivalent nito ay 1 cubic decimeter. So, 1 liter is the volume equal to 1,000 milliliters. 1,000 milliliters or 1,000 cubic centimeter. So, ibig sabihin, ang 1 milliliter ay katumbas niya rin ang isang cubic centimeter or 1 cc. So, 1 millimeter is equal to 1 cubic centimeter. So, yun. Ang susunod natin i-discuss na ngayon is, wait lang. Of course, yung density. It is a derived measurement din. Derived from, ano ba ang unit ng density? Ang dimensional analysis ng density ay mass over volume. Mass over volume, or D is equal to M over V. In higher sciences, ang symbol ng density ay yung Greek letter rho. Pero in this videos, since we are nagdi-discuss pa lang tayo ng mga fundamentals ng chemistry, so we'll just use D for that matter. So, density is actually an intensive property. So, na-discuss na natin yung intensive and extensive property. Yung intensive property is that it is a property na na regardless nung quantity na kukunin mong sample, yun at yun pa rin ang density. Like for example, kumuha ka ng sample sa isang malaking container, yung density ng makukuha mong sample ay the same sa density ng buong container mo. So, intensive property does not depend on the quantity of mass present for a given substance. The ratio of mass to volume always remain the same. In other words, the volume increases as the mass does. So, directly proportional sila at a constant density. Ang isang property lang ng density ay density usually decreases with temperature. So, bumababa yung density kapag tumataas yung temperature. And yung explanation dyan is siguro i-discuss natin further sa mga susunod pang video. But, kumbaga, i-accept lang muna natin yung fact na the density usually decreases. Usually, ibig sabihin hindi applicable ito sa lahat. There's always an exception. But the general trend for most of chemicals, density usually decreases with temperature. So, meron tayong table dito ng density. Papakita ko. Okay. Ito. So, yan. So, for example, ito, air, ang density niya in gram per cubic centimeter ay 0.001. Meron tayong, well, actually, merong ito. Itong, kaya siya may asterisk that ang nakasulat dito sa footnote is that measured at 1 atmosphere. So, mineasure to at 1 atmosphere. Meron naman tayong ethanol na 0.79 ang density. And meron tayong water na 1.00. So, ibig sabihin, alin ang mas denser dito sa tatlong ito? Ito ang pinaka-dense, ito yung medyo dense, at ito yung less dense, least na ang density dito sa tatlo. Then, punta naman tayo sa mercury. Ang mercury ay 13.6 gram per cc. Then we have table salt. Then we have iron, 7.9. Then we have gold, 19.3. And then we have osmium. Osmium is the densest element known. Ito yung pinaka-dense na substance known. So, yun. So, ibig sabihin, itong mga substance na ito, mas dense siya sa water kasi 13.6, 2.2, 7.9, 19.3. Kung i-arrange mo itong limang to, ang pinaka-light, ang pinaka-least dense sa kanila ay itong table salt, followed by iron, then followed by your mercury, then followed by your gold, then the densest of them all is osmium. And osmium, as I will repeat, is the densest element known. So, para ma-practice tayo, mag-solve tayo ng problem. So, open tayo ng MS Word. MS Word. So, yun. Okay. Yan. Tapos, paste natin lang itong problem para makita natin. Yan. So, basahin natin. A gold is a precious metal that is chemically unreactive. It is used mainly in jewelry, dentistry, and electronic devices. A piece of gold ingot with a mass of 301 gram has a volume of 15.6 cubic centimeter. So, calculate the density of the gold. So, alam natin na ang formula for density is D is equal to M over V. Yan. Then, we will just substitute the value 301 gram for the mass, and we will just substitute 15.6 sa volume. So, it will just simply look like this. Ganyan. So, yun. Then, pag kinalculate natin yan, ang lalabas sa sagot ay 19.3 grams per cc. So, kopyahin natin yun dito. Yan. And this is your answer. So, ilagay lang natin sa sa box. Yan. Yung final answer. Then, isa pang example para ma-practice pa tayo. So, another example. So, the density of mercury, the only metal that is a liquid at room temperature, is 13.6 gram per ml. So, calculate the mass of 5.50 ml of the liquid. Okay? So, dito naman, ang mangyayari, since ang hinahanap natin mass, i-rearrange lang natin yung formula natin for density in such a way na ang hahanapin natin ay yung mass. So, ang kalalabasan niyan ay ganito. Mass is equal to density times volume. Then, isusubstitute lang natin yung mga values ng density. Ang density ay 13.6 gram per ml. Then, yung volume natin ay 5.50. So, it will look like this. So, 13.6 gram per ml times 5.50 ml. So, if you notice, yung ml dito, tapos yung ml dito ay magka-cancel out, making this equation dimensionally correct. Kasi mass is equal to blank gram ang magiging sagot. So, mass is, pag kinompute natin yan, kinalculator natin yan, ito magiging sagot. Mass is equal to 74.8 grams. Okay. Box lang natin for final answer. So, ganun lang naman ang pag-solve ng density given yung mass and volume. And the second one is computing for mass given the density and the volume. Kung given naman tayo ng volume, given tayo ng density at ng mass at gusto natin hanapin yung volume, pwede rin yun. Pwede rin yun. I-manipulate lang natin to. So, i-change lang natin yung position nitong volume sa density. So, ang magiging equation mo dyan is dito yung volume at dito yung density. Yan. Ganyan yung magiging computation nyo. So, yun na muna sa ngayon ang ating discussion for measurement. We will continue our discussion for measurement sa susunod. Ang next discussion na natin ay temperature scale. So, kita-kita tayo ulit doon ha. Thank you for pag-listen. And sana may natutunan kayo.